Hello, today we're going over section 3.4, which is using square roots to solve quadratic equations. When there's only one x value in the equation, another option besides factoring is a square root principle. To do it, we want to isolate our x value, square root both sides, and look at both answers. Now, in this, usually the situation, it's an x squared term. We don't have essentially our b term. So for example, we've got x squared minus 9 equals 0. First thing I would do is move the 9 to the other side. So you have x squared equals 9. At this point, we can take the square root of both sides, and we get x is equal to positive or negative 3, because technically whenever we take the square root of something, we can have a positive number or a negative number. Okay, next one, x squared minus 15 equals 10. So I would add 15 to both sides. So that gives me x squared equals 25. Take the square root of both sides. So that gives us x is equal to plus or minus 5. Okay, next one, we have 4x squared minus 36. So once again, I'll move the non-x squared term to the other side. So I'll add 36 to both sides. So we have 4x squared equals 36. Now in this case, I have something in front of my x squared that I can divide both sides by, so I'll do that. So that gives me x squared equals 9. We'll take the square root of both sides. So that gives us x is equal to plus or minus 3. Next, we have x squared minus equals 7. So if we go to take the square root of this, we can't get this broken down anymore. So we'll say x is equal to plus or minus root 7. So if it's not a perfect square, we can leave it as a radical. If possible, we'll change it to mixed radical, but in this case, we aren't able to. Next one, we have x minus 5 squared equals 25. So our squared part is on its own, which is good. So we can simply take the square root of both sides. So that will give us x minus 5 is equal to plus or minus 5. Now in a situation like this, where we have more than just our x on the one side and plus or minus something on the other side, we'll break it down into two separate equations. So we'd have x minus 5 equals positive 5. We will also have x minus 5 equals a negative 5. In this case, move 5 to the other side. So we have x is equal to 10. In this case, we'll do the same thing, but we get x is equal to 0. Next one, we've got x plus 1 squared plus 2 equals 0. So our squared term is not on its own. So what we want to do is move the 2 to the other side. So that gives us x plus 1 squared equals negative 2. Next, we'll want to get rid of the square root by taking, the squared by taking the square root. So we'll do that to both sides. However, we can see here that we have no solution. And that is because we cannot take the square root of a negative number. So anytime you're trying to do this and you are going to take the square root of a negative, it's going to be no solution because you can't actually do that mathematical operation. Now, when you can't factor or square root to solve, we can also use something called completing the square. So this is very helpful with trinomials where we have all three values, so an A, a B, and a C, and we're not able to do product sum factoring with it. So on this page, we'll go over steps and then we'll do an example of it on the next page. So first step is insert blanks after the second and third terms. Now, these steps refer to if we have something of a form of x squared plus bx plus c. We'll get into later on what happens if we have an a in front. So step one, insert blanks after the second and third term. So essentially we would have x squared plus bx, we'd have a blank plus c, and then another blank. And in that first blank, we put in a number that makes the first three terms a perfect square trinomial, which we divide the b value by 2 and square it. So essentially b divided by 2 and squared. And that will go in this one. Now that will be a positive value. And then the next one will be a negative value because we're not changing the equation if we add a positive value and negative value that are the same. We would then put brackets around our first three terms because we create a perfect squared trinomial of this. We would then factor this, combine like terms here, and then from there, we want to solve using the square root principle. So for example, we've got x squared minus 14x plus 33 equals 0. So first step is putting in our blanks. So x squared minus 14x. And then we've got blank. We know this one's going to be our positive one. So I'll put plus a blank, then plus 33. And then this one we know is negative. So I'll put minus a blank equals 0. In that blank is our b value divided by 2 and squared. So in this case, our b value is negative 14. So we have negative 14 divided by 2 squared. So that's negative 7 squared. So that is 49. Now, what that does is creates a perfect squared trinomial. So this to factor, we know that to factor, we can take the square root of this, which is x, square root of this, which is 7. And then this was a minus, so this will be a minus. So x minus 7 squared. We then combine these two terms, so 33 and negative 49 will give us negative 16. At this point, we can use our square root principle to solve this. So I'd move the 16 to the other side. So I have x minus 7 squared equals 16. At this point, take the square root of both sides. So that gives us x minus 7 is equal to plus or minus 4. So I'll break this into two equations. So x minus 7 is positive 4, as well as x minus 7 is negative 4. Move the 7 to the other side. So for the first one, we get x is equal to 11. The next one, when we move the 7 over to the other side, we get x is equal to 3. If we have a coefficient in front of our x squared term, the only difference in what we do is we can either factor or divide it out first. So for example, solve, we've got 2x squared plus 8x plus 5. So I'll divide out that a value. So I'll divide everything by 2 on both sides. So I've got x squared, then 8x divided by 2 is 4x. 5 divided by 2 will leave as a fraction, so that's plus 5 over 2. And then 0 divided by 2 is 0. So now I'll rewrite this with blank. So x squared plus 4x plus a blank plus 5 over 2 minus a blank equals 0. In our blank is our b over 2 squared. So we have 4 divided by 2 squared. So that is 2 squared, which is 4. So we have plus 4 and minus 4. Now we have our perfect square trinomial, which once again, to factor it, we take the square root of our x squared term, which is x, square root of 4. So that's 2. Middle term was positive, so it's plus 2. So it's x plus 2 squared. And then we'll combine 5 over 2 and negative 4. I'll do that over here. So 5 over 2 minus 4. We need the same denominator. So I'd multiply the top and bottom of a 4 by 2. So that gives us 5 over 2 minus 8 over 2 gives us negative 3 over 2. Next step, we'll move the 3 over 2 to the other side. So we have x plus 2 squared equals 3 over 2. We'll then take the square root of both sides. So that gives us x plus 2 equals plus or minus root 3 over 2. We'll move the 2 to the other side by subtracting it over. So we have negative 2 plus or minus the root of 3 over 2. Now we can combine this into a single fraction. We just have to do a little bit of work to be able to do so. So this is the same as saying x equals negative 2 plus or minus root 3 over root 2. Which we can multiply the top and bottom by root 2. And we'll continue this up here. So we have x is equal to negative 2 plus or minus root 6 all over 2. We'll multiply the negative 2 by 2 over 2. So that gives us x is equal to negative 4 over 2 plus or minus root 6 over 2. If they have the same denominator, so we can combine them. So x equals negative 4 plus or minus root 6 all divided by 2. Okay, so practice for a section is starting on page 222.